Iron ore is mined. I'm going to read from the book, page 36, right-hand column, underneath the bolded items. Iron ore is mined by the underground and open pit methods. The method chosen primarily depends on the depth of the ore body below the surface and the character of the rock surrounding the ore body. In underground mining, a vertical shaft is sunk in the rock next to the ore body. Tunnels are drilled from this shaft and blasted horizontally into the ore body at a number of levels. Open pit mining, the mineral is lying relatively near the surface. The earth and rock covering the ore body are first removed. Blast holes are then drilled and explosives shatter the ore to permit easy digging. The loosened ore is hauled out of the pit by truck, train, or conveyor belt. If you look at figure 3.1, it shows you the breakdown here. Okay, so here's the basic portions as well. We're starting, it is mined, works its way all the way around to the plant, concentrator, rock crusher, and then it starts up here at the mine and works its way down. You crush it first, then it comes down into different processes, and we're going to talk about those being shipped off to the steel mills. Okay? Basically, underground, just kind of give you an overview of what's there. Underground means that you're going to drill holes down in large enough for you to go through. For example, some of the trona mines that I've worked at underground have been roughly a 9-foot ceiling, anywhere from, the main shaft going down can be roughly 45 feet across. Okay? You can jibe vehicles and small vehicles designed for mining within them, so forth. Open pit usually means there's not any underground tunnel. They will start taking the surface off, just like an auger, to get all the way down to the bottom, and then they will haul it out of the pit, take it back too. One thing that's important about, most people don't understand about mining is that, sometimes mining gets a really bad rap, and we're not going to get into that whole aspect of the environmental portion by any means. What I do want to say is that, one of the good things about the MSHAs and some of the current government codes is that has to be, at some point, it has to be replaced back to its original shape. There are a lot of restrictions in there. So for example, your topsoil has to be separated to make sure to restore it to its original portion once it is done being mined. Okay. Just wanted to talk a little bit about that, just so you understood that technically there are a lot of old mines out there that were never cleaned up correctly. Modern day society and regulations make sure that it has to be reclaimed and put back to the original state. They will survey it and it has to be put back there. All right, moving on. Oxygen. Reading out of the book, page 37, left-hand column. Oxygen is the most abundant element on Earth. Almost half the weight of the land, 21% by weight of the air, and nearly 90% by weight of the sea consist of oxygen. Next paragraph down. The steel industry is a major consumer of oxygen. The gas goes into most of the standard steel mill processes, from the blast furnace to the finished product. This is definitely a bolded item coming out of the book. Oxygen is used in the steel making process to purify the material. Right here on the PowerPoint as well, it's used to purify the material. When directed onto the surface of molten iron, it oxides the carbon, silicon, manganese, and other undesirable elements. It also speeds up the steelmaking process by supporting the combustion of other fuels. These oxy-fueled flames provide much higher temperatures than fuels burned in air. So again, oxygen itself does not burn. You might see that on several tests throughout the program. Oxygen itself supports combustion. It does not burn on its own, okay? Fuels, 3 major natural fuels. And I think that, I guess it's technically considered a heating source. We'll talk about that in a second. 3 major natural fuels: coal has been the most important up until recent. Oil and natural gas, okay? More modern regulations with environmental impact studies have been done to where they are trying to limit the use of coal, oil, natural gas. Now we're looking at other ways to produce it. Part of the other reason for that is some of the advancements in technology we've had with inverter type transformers, solar power, wind power generators. And, you know, I guess one of the main fuels, or one of the main things that's replacing fuels, is electricity, induction furnaces. However, electricity is made in a power generation plant. Usually they're having to have some sort of a fuel source to power that. And there's nuclear power plants, there's coal-fired power plants, there's wood and paper power plants. Okay, there's also hydroelectric, especially on this part of the country where we have more water. Some places in the Rocky Mountain region, there's not that much water. New Mexico, Nevada, and so forth, very limited to where hydroelectric power is not very easily obtained. Okay. It's important to know not just what we have here locally, but what we have across the nation and the world, by all means. But if you're getting into a trade like this, there might be times that you have to go somewhere else and work. You may go across seas, but more than likely you'll stay within a region, and you'll possibly travel quite a bit. We have a lot of work around us from California, Nevada, all the way across Colorado, New Mexico, Wyoming, Montana, North Dakota, Washington, and so forth. And each one of them has a lot of very good natural resources that they use. All right. Okay. Moving on. Let's break down coal. And I believe this statistic has changed. There's still it's still a pretty high percentage, believe it or not. I still believe it's like 45 to 50% of heat and energy requirements overall. And I believe that at the time this was wrote, it was at 80%. Okay, moving on. Coal supplies more than 80% of the iron and steel industry total heat and energy requirements. Go down to the bottom of that paragraph, 1, 2, 3, 4 sentences up, 4 lines up. Right hand side, it starts out, a paragraph starts out, and this is a bulleted item. A large part of the coal is used in making coke for use in the blast furnace. About 1,300 pounds of coke are used for each ton of pig iron produced. 1,300 pounds of coke. Okay. Not all types of, I'm going to read from the book, not all types of bituminous coal can be used to make coke. Coke must be free from dust, the right size to permit rapid combustion, strong enough to carry the charge in the blasting furnace, and as free as possible from sulfur. Coal of coking quality is mined in 24 states. However, West Virginia, Pennsylvania, Kentucky, and Alabama supply nearly 90% of the coal used in the steel industry. So coke is a byproduct of coal. It has been stripped of some of the stuff within it to get a higher BTU content out of it. So forth. Oil. Okay, so we skipped a couple pages here. We're on page 43. Oil is used as both fuel and a lubricant. Heaviest grade of oil most commonly used. Percentage of use. Fuel oils was getting rather expensive as well. So it's not nearly as used on a large industrial scale as it is more of a residential scale, small furnace type scales. Okay. Natural gas. Many of the existing coal burning power plants are switching over to natural gas due to cleaner emissions and so forth. It's burning for you can get high, especially with modern technology, compressors and purifying of the gas and so forth, and you can add some chemicals to it to help it produce less emissions. And sorry, I forgot where I was going there. So we're getting a lot higher BTU range out of the gas than we were 10 years ago, even 5 years ago specifically. Quite a bit more. Okay. So just real quick, 1,000 BTUs per cubic foot. You can get higher than that now. Steel industry consumes over 400 billion cubic feet per year. 50% of it is used in heat treating and annealing furnaces. All right, let's talk about coke. Supplies heat for smelting iron in a blast furnace. I'm going to read from the book, okay? Page 43, left-hand column underneath coke. The heat required for smelting iron in blast furnaces obtained from the burning of coke. Coke may be defined as the solid residue obtained when coal is heated to a high temperature in the absence of air. This causes the gases and other impurities to be released. Coke is a hard, brittle substance consisting chiefly of carbon, together with small amounts of hydrogen, oxygen, nitrogen, sulfur, and phosphorus. We're going to go switch over. It's a hard, brittle substance consisting chiefly of carbon. 1919, coal chemical processes of producing coke developed. That's the top right-hand column. Start off there. By 1919, the coal chemical process of producing coke was developed, and coke became the leading fuel of the steel industry. The process, in addition to recovering the chemicals as coal, makes possible the production of stronger coke from a greater variety of coal. You look on the left-hand page, last couple pages before, there are some illustrations with a lot of pictures. Feel free to look through them. We're going to continue on. It was the leading fuel of the steel industry. Some recent environmental protection regulations have switched it mainly over to electricity, and the electrical power generation plants are looking at other alternatives as well. Okay. Let's go to steel scrap. Oxygen furnaces capable of using scrap. Okay, 66% of the steel used is recycled. That's a bulleted item. I will stick to the book instead of the modern numbers. I believe now it's like 73 or 74% for test purposes. Out of your book. So I'm going to read from the chapter here, okay? It's underneath steel scrap, page 43, right-hand column. The earliest methods of making steel could not make use of scrap. Today's basic oxygen furnaces, BOFs, which include early blast furnaces and electric furnaces, are very capable of using scrap, and nearly 66% of the steel currently used is recycled. Steel, and that's a bulleted item, steel is generally made using a continuous caster that produces slabs, billets, or blooms. I would know those three items there. We'll talk about them further, but I would highlight and circle slabs, billets, or blooms. A blast oxygen furnace, or a basic oxygen furnace, may take up to 80% liquid metal directly from the blast furnace and then have up to 20% scrap added. An integrated producer using this method can better control and produce higher grades of steel than a steel maker who simply melts scrap. Go down 3 sentences. It starts out, blast furnaces do not use scrap except in the form of sinter, a powdered form. Okay, continuing reading from the book. Steel mills recycle any of their own product that is not usable, and they also recycle items such as packing cases. However, one of the best sources of scrap steel is from old automobiles. Scrap steel has become such a valuable commodity that the American metal market actually tracks the price of certain grades of scrap daily. And that is still very true. The higher the grade the material, the higher the price you get. Okay? Limestone. Limestone is used as a flux in the blast furnace. It is a sedimentary rock commonly found all over the world. There are large deposits in many parts of the U.S., especially in the Appalachian Mountains, Rocky Mountains, and the Mississippi Valley. Page 45, left-hand column, bottom paragraph starts out, limestone is one of the chief fluxes used in steel making to separate the impurities associated with iron ores are of a highly refractory nature. That is, they are difficult to melt. If they remained unfused, they would retard the smelting operation and interfere with the separation of metal and the impurities. The primary function of limestone is to make these substances more easily fusible. Figure 3-6 shows the steps taken to process limestone. So basically they're the flux that helps bond the refractory materials that are hard to get to, or difficult to fuse together, okay? Refractory materials, a non-metallic material which can tolerate severe or destructive surface conditions at high temperatures. Skip down there. The main portion of that paragraph underneath refractory materials is just looking at these temperatures. 2600 degrees for light duty fire clay, 5000 degrees for magnesia brick, okay? Underneath refractory materials, second paragraph down, bolded item, refractory materials have an almost unlimited number of applications in the steel industry. Among the most important are linings for blast furnaces, steel making furnaces, soaking pits, reheating furnaces, heat treating furnaces, ladles, and submarine cars. So not only do they help stuff fuse together, but they also help keep it from sticking to the ladles, okay? As pouring, when they're pouring it. Going to read from the book, page 45, right-hand column, bottom paragraph. Refractory materials are produced from quartzite, fire clay, alumina, which in parentheses, aluminum oxide, magnesium oxide, iron oxide, natural and artificial graphites, various types of coal, coke, and tar. The raw materials are, bolded item, the raw materials are crushed, ground, and screened to proper sizes for use in making bricks and other forms of linings. Page 48 now, bottom sentence in that top left-hand column. Most refractory bricks are fired in kilns at high temperature to give them permanent strength. Power pressing, extrusion, hand molding. All right. Iron blast furnace slag. Reading from the book, bolded item. Slag is the residue produced from the interaction of the molten limestone and the impurities of the iron. It contains the oxides of calcium, silicon, aluminum, and magnesium, small amounts of iron oxide and sulfur. Slag may be processed for use in the manufacture of cement and concrete blocks, road materials, insulating roofing material, and soil conditioner. all the things that slag can be used for. This is a lot of stuff that we sometimes don't think about. We think of slag as just being a bad product. It's not always the case, okay? Carbon. Carbon is a nonmetallic element that can form a great variety of compounds with other elements. Reading from the book, continuing on, underneath carbon, second paragraph below that, in union with oxygen, carbon forms carbon monoxide and carbon dioxide. When carbon comes with the metal, or when carbon combines with the metal, it may form compounds such as calcium carbide and iron carbide. Well, we know calcium carbide can be used and can be aided in the reproduction of acetylene gases as well, correct? Okay. Next reading on, this is a bulleted item. 3 forms of pure carbon exist. The diamond is the hard crystalline form, the graphite is the soft form, and carbon black is the amorphous form. In addition to being important as an ingredient of steel, carbon is used for industrial diamonds and abrasives and art carbons of all kinds. As graphite, it forms a base for lubricants and is used as a lining for blast furnaces. The smelting of iron. The blast furnace. Bulleted item, reading from the book, page 48, left-hand column. The blast furnace. The first step in the conversion of iron ore into steel takes place in the blast furnace. In these towering cylindrical structure, iron is freed from most of the impurities associated with it, is freed from most of the impurities associated with it in the ore. The furnace is charged with iron ore, limestone, and coke. A blast of preheated air burns the coke, producing heat to melt the iron, which falls to the bottom of the furnace. The molten limestone combines with most of the impurities in the ore to form a slag that separates from the liquid iron because it is lighter and it floats. The liquid iron and the liquid slag are removed periodically from the bottom of the furnace. This is a continuous process. As a new charge is introduced at the top, the liquid iron and slag are removed at the bottom. The progress of the charge through the furnace from the time it enters the top until it becomes iron is gradual. 5 to 8 hours are required typically. So, the furnace has ore, limestone, and coke. So we've got a fuel source, something we're melting, and then we've got the slag to help draw it out, correct? Very similar to a welding rod. Just to, again, we can go into a lot more detail, but just to kind of give you an idea of how it works. Think of your welding rod. You strike the arc, so the electricity is the coke. That's the fuel source that heats it, okay? The iron ore is the steel within it. The limestone is the flux around your steel, around your electrode. So it's exactly what happens. As this melts and heats together, the limestone is your slag, and it produces the flux and pulls the impurities out to the top of the weld, okay? Same thing there's always more technical, but the concept is the exact same thing, all right? Exactly what we're talking